All right, we're going to start here today by flipping over some more complicated lines, some more complicated reflections. And we'll start by looking at y equals 1. Now, when we graph y equals 1, obviously that means that y is going to equal 1. So what does that actually tell us? What that tells us is it doesn't matter what the x-coordinate is. So over on the right, we have y equals negative x. If I put in different values for x, I'm going to get out different values of y. But over on the left with y equals 1, it doesn't matter what I put in for x. I'm always going to get that y coordinate of 1. So if x is 0, well, y is 1, because y is always going to be 1. If x is 5, y is still 1. If x is negative 3.7, y is still 1, because y is 1 no matter what. So this results in a horizontal line. And a way you can remember this is that if y is in charge of up and down, and y is always 1, that means how far up and down I go doesn't change the whole time. The y-coordinate is always 1. So it doesn't change any up and down horizontal line. So when you see x equals, it'll be a vertical line, because then left and right is never changing at all. So let's flip over this line, and we're going to do that all on the graph, and then we'll make the points. So A, from that line, A was 1 above that line. So instead of going 1 above, I'm going to flip that and go 1 below. There's A prime. B, if we count, was 1, 2, 3, 4, 5 above that line. So instead of being 5 above, it's going to be 5 below. Here's B prime. And then same thing for C. C was 1, 2, 3 above. So now it's going to be 1, 2, 3 below the line. Here is C prime. So there's all 3 of my points. And so I'm going to write out where they went. So it was 4, 0. It was 5, negative 4. And it was 6, negative 2. Don't forget to write out those coordinates each time that you're doing this. Now, if I'm graphing y equals negative x, for some of you, it might help if I write it as negative x plus 0, so that you remember that that's slope-intercept form. So that means the y-intercept is at 0, 0, and then the slope is negative 1. So I can go down 1 to the right 1, and down 1 to the right 1, or up 1 and to the left 1, up 1 and to the left 1. So I'm going over y equals negative x. So that should help give you a visual of where this should end up. But I'm going to come down here and use the coordinate rule. xy moves to negative y, negative x. So what we're going to do each time is we're going to switch x and y, and then we're going to change the sign of both of them. So for A prime, we're going to switch and then change their signs. So 4, 2, switch them to 4, and then change both of their signs. They're both negative. Let's do it again. For B prime, switch x and y. So 5, 6 becomes 6, 5. Change both of their signs. Now they're both negative. And one more time. 6, 4 becomes 4, 6. And we change both of their signs. So now if I come and make that on the graph, here's A prime, here's B prime, and here is C prime. There's my new triangle flipped over y equals negative x. Switch x and y, change their signs. So that's about as complicated as those reflections get. Usually you're flipping over the x or y axis, but occasionally we have these curveballs of these more complicated lines that we're flipping over. All right. Moving on, we're going to look at compositions. And for the most part, there's not much that is new. All that is new is that we are doing 2 transformations on top of each other. So we're taking a shape, doing a transformation to it, and then taking that new shape, doing another transformation to get an even newer shape. So when we do that, the notation we use, we have this A prime A prime right here. But for the second new shape, the newer shape, we can't use A prime again, so we've already used it. So our solution is going to be to put another set of primes on there. So that's why this is a double prime, to say that this is the second transformation that's happening, the transformation of the transformation. So we're going to do a transformation, and then we're going to take that new shape and do another transformation to it. Now, an important thing to note is that whenever we describe these transformations, we want to make sure we're specific in describing them. All right, so we're not just going to put translation, rotation, reflection. When we say a translation, we're going to say how far, in what direction. So a transformation this far to the left and this far down. Or a reflection over the x-axis versus a reflection over the y-axis gives me different reflections. So we want to make sure we're saying how far we're flipping over, what we're flipping over. And with rotations, 90, 180, 270, don't just put rotation, put how far that rotation is going. And we're going to describe it counterclockwise. So we're going to put counterclockwise as well. So we'll do transformations and we'll describe transformations. So let's do a couple of those. All right. So starting with point A at 3, 2. So I'm going to go ahead and put point A there. And we'll just do it with point A, and then I'll have you do it with points B and C. So first off, we're going to do a translation, and that minus 12, let's think about what that minus 12 is going to do. Well, since it's x, that's in charge of left and right. So taking x, subtracting 12 means that it's going to move to the left 12. So the idea is that this is transformation number 1. And then this will be transformation number 2. So if I want to go to the left 12, well then I'm going to shift it and count 12 to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to the left will wind me up here for A prime. Which, if you look at those coordinates, so A was at 3, 2, A prime ends up at -9, 2, which hopefully makes sense because we said we'd take that x coordinate, subtract 12. 3 minus 12, that's a -9. Then, to get A double prime, we're going to take A prime. We're going to take A prime. We're going from A prime. We're reflecting it over the x-axis. So here's my x-axis. So we're going to flip it. Well, it was 2 above the x-axis. So now we're going to count 2 below the x-axis and put A double prime. So again, we're going from that first transformation and then working through to that second transformation. So A double prime is at -9, -2. And if you look at your coordinate rule for a reflection over the x-axis, that should line up. So that's your point with A. Now I want you to pause here for a minute and work out the transformations for points B and C. So that means here's point B and here is point C. So we start with this triangle and we're taking that triangle, shifting it to the left 12 and flipping it. So take a minute, pause here and look at where those points go. And we're coming back and we look, and here in my beautiful handwriting, handwritten, hand-drawn, pristine diagram, it's showing my shifting to the left 12 and my flipping over the x-axis. And notice all the coordinates are written there. This called it a glide reflection, and hopefully you see why it's called a glide reflection. because that translation is going to glide it across to the left, and then the reflection is going to flip it over. So it glides across and then it flips. All right, let's do a couple more. So we have 2 points, C and D now. And we're doing two transformations. So we're doing a reflection and then we're doing a rotation. So first off, reflection in the y-axis. Let's graph the y-axis. There's our y-axis. And we're going to flip this. So we're looking at how far left and right we were, and we're going to flip it. So C was 2 to the left of that y-axis. So instead of going 2 to the left, flip it, go 2 to the right, C prime. D was 1 to the left, so now it's going to flip, go 1 to the right, D prime. So there's my new segment flipped over the y-axis. Change my direction of left and right. So C prime is now at 2, 6, and D prime is now at 1, 3. So that's my reflection. Flip my left and right directions. Then the rotation, let's write out the coordinate rule for that notation or rotation. XY moves to negative YX. That means that we are going to switch X and Y, change the sign of the first coordinate. Again, it's the same idea we talked about yesterday, and we're going from C prime. From C prime, which is at 2, 6, to get C double prime, switch X and Y, so 2, 6 becomes 6, 2, but the first coordinate gets its sign change, so now it's negative. For D double prime, we're going to do the same thing. So we're going to switch X and Y. 1, 3 becomes 3, 1, but that first coordinate change its sign. So now it's a negative 3, 1. So negative 6, 2, here's C double prime, and negative 3, 1, here is D double prime. So we're just doing a transformation and then doing another transformation on top of it. We reflected, and then we took that reflection, turned it, and that gave us our final answer. Now, let's look at one where the transformations are done for us and we need to describe them. So first question is, how do we know which shape is the original, which shape is the first transformation, and which shape is the second transformation? And hopefully we remember that we are going to check the primes. We're checking the primes. So this is my original shape right here, A, B, and C. Then it moved. So my original shape, I'm actually going to label this 1 here. My original shape got moved here to A prime, B prime, and C prime. That is transformation number 1. Then from there, A prime, B prime, and C prime moved up here to create transformation number 2 to A double prime, B double prime, C double prime. So let's describe each one. Remember, we're going to be specific here. So for the first one, remember, we're looking at translation, which is shifting, rotation, which is turning, or reflection, which is flipping. So for this one, to get from A, B, and C to A prime, B prime, and C prime, this is going to be shifting. The whole triangle got shifted down and to the right. So this is going to be a translation. And we need to be specific when we're describing it. So I'll describe it 2 different ways. 2 different ways you can be specific with it. You can either track how it's moving or write the coordinate rule. So for example, let's take point C, because they should all move the same way. If we count, we're going to go to the right, 1, 2, 3, 4, 5, and down 1, 2, 3, 4. There's C prime. To the right 5, and down 4. Or you can write the coordinate rule. If you're writing the coordinate rule, xy moves 2. Well, right 5, that's an x direction, and it'll be plus 5. Down 4 is a y direction, and it's minus the 4. So xy moves to x plus 5, y minus 4. You can either have this or have this, but you need to have one of them, so that you're specific, not just saying translation, but how is that translation moving? I should be able to look at your description and be able to do the transformation myself. So for transformation number 2, we're looking at how B gets to B prime and how B prime gets to B double prime, how C prime gets to C double prime. And again, translation, shifting, rotation, turning, reflection, flipping. This time we are flipping. It's a reflection. Reflection, and then we should say what we're reflecting over. Well, we're reflecting over the x-axis this time. Right? The x-axis is what we're flipping here. Or if you wanted to write the coordinate rule for reflection over the x-axis is xy moves to x negative y. One of these two ways of writing it. You need to be specific enough that I can do the transformation just by reading your description. So that's my descriptions of the transformations.